Hi everyone! In this video, I'm going to create this M6 bolt together with Nat and create a simulation that you see in front of you. So without further ado, let's get right into it. So the first thing I'm going to do is I'm going to create a new part. I'm going to start, mechanical design, and part design. I'm first going to create the M6 bolt. So I'm going to name the part M6 bolt and click OK. I'm now going to go into Sketch of Workbench and I'm going to create a new sketch on the YZ plane. I'm going to click on the profile command and I'm going to sketch out 1/2 of the profile of the bolt. I'm not concerned about dimensions at this point because I will constrain everything afterwards. Perfect. Rough profile has been sketched in, so I'm going to double click on dimensional constraint and I'm going to click on this line. I also want to define thickness of the head, diameter of the bolt head, and major diameter of my bolt. Now because this is an M6 bolt, the radius is going to be 3 millimeters. The thickness of the head is going to be 6 millimeters. The diameter of the bolt head is 10 millimeters, so the radius is 5 millimeters. And then the length is something I chose to be 40 millimeters. I'm going to exit the Sketch of Workbench, and I'm going to use the shaft command to revolve this around its axis. So because I already clicked on the sketch prior to clicking on the command, sketch 1 is already selected in selection for the profile. But for the axis, I'm going to right click here and click on Z axis and click OK. Perfect. Now the next thing I'm going to do is I'm going to create a point. If you want to create a point outside of Sketch of Workbench, you need to be looking into this group of commands. These are called reference elements. If you don't see these commands anywhere on your screen, just right click on any of the icons and make sure that reference elements, either compact or extended, are enabled. I'm going to click on point and I'm going to create my point on the edge of this circle. Now I can drag my cursor and create a point anywhere, but in here, in this window that appeared in the bottom right corner, I'm going to define the length to be 0 millimeters because I want the point to be exactly on that circle, on the edge of that circle. Hit preview and click OK. Perfect. Now, the second thing I need to do, I need to create Helix. Now, Helix is a command which is not contained in the part design workbench. So you have two options. You can either go into Start, Shape, and go into Generative Shape Design. And then in here, you can go into Insert, Wireframe, and Helix. Now, alternatively, you can stay in part design workbench and down here in the command window, type in C:(Helix). Hit enter. And this brings the dialog window of the Helix command, even though you are not in generative shape design. Okay, so for the starting point, I'm going to click on the point that I created. And for the axis, I'm going to right click here and I'm going to click on the Z axis. Alright, so for the pitch, I'm going to choose 1 millimeter because M6 coarse thread by standard has got a pitch of 1 millimeter. Now for the height, I'm going to choose 30 millimeters and I'm going to keep everything else default. Click OK. Alright. Now, the next thing I'm going to do is I'm going to create a plane. I'm going to click on this plane command and I want to create a plane on this helix. And I want to create a plane which is normal to this helix at this point. So after I clicked on the helix, in the bottom right corner, the plane type has automatically changed to normal to curve. Now this is what CATIA usually does. It automatically detects what kind of plane is best for certain situations. So if this didn't appear on your screen, just click on this menu and choose normal to curve. And for the point, I'm going to choose this point that I created before. You get a little highlight of your plane and you can go ahead and click OK. I'm now going to create a sketch on this plane that I have just created. And essentially, I'm now going to create a profile of my thread. So the first thing I'm going to do is create an axis. This will be a horizontal axis. I'm going to click on the line command and just a rough line here. I'm now going to click on the mirror command because I want to make sure that whatever I do on one side gets reflected on the other side as well. I'm now going to create a line from this point to this point, and another one from this point to this point. Okay. I'm going to define the angle between this line and horizontal to be 30 degrees. Distance between this and this must be 3 millimeters. This length must be 0.125, and this length must be 0.541. Okay, exit the sketch of Workbench. And I'm now going to click on the slot command. And for the profile, choose the sketch we have just created. And for the center curve, click on the helix we created before. Now you get a little preview, but as you can see, even from the preview, it looks like this is not what we actually want. In the profile control, instead of keep angle, click on pulling direction and choose the axis of the bolt. Click OK. Close off this warning, and as you can see, this cuts the thread for us nicely. One last thing to do, if you zoom in, you will notice that the thread ends up abruptly. So you basically have a section where you have thread and then suddenly it stops. This is not very nice and actually not very realistic. So if you want to modify this, double click on your thread, and in here, make sure that the merge slots ends is enabled. And click OK. Close off the warning, and as you can see, this nicely blends the thread with the bolt. Same thing at the bottom. Now the next thing I'm going to do is I'm going to create a sketch on this face, and I'm going to create a hexagon, and the faces of the hexagon are going to be 5 millimeters apart. Exit, and use the bucket command to make a bucket which is 3 millimeters deep. I'm now going to create a chamfer, which is going to be 0.5 millimeter in length and 45 degrees in angle. Click OK. I'm going to create a very subtle radius on this edge, 0.25 millimeters. And the last thing to do on this bolt is to create a chamfer in here at the bottom. As you can see, this is very sharp. So unfortunately, we can't just use chamfer commands because this geometry is not suitable for chamfer command. So what I'm going to have to do is go into the ZX plane or YZ plane, doesn't matter. Create a new sketch. And we're going to sketch in the chamfer manually. So I'm going to create a rough chamfer, something like this, a triangle like this. And I'm going to define the distance in here to be 3 millimeters. The angle in here is going to be 30 degrees. And this length is going to be 0.5 millimeters. Exit the sketch of Workbench and use the groove command to cut away the material. For the axis, you can either choose Z-axis or you can just hover above your component and the axis appears. And click OK. And as you can see, this is much more realistic. Perfect. I'm just going to go into properties and I'm going to change the color of this bolt to be a bit darker. Apply and click OK. Great. So the bolt has been created. You can go ahead and save this. So go into File, Save, name this M6 bolt, and click Save. The next component is going to be the nut. So click on Start, Mechanical Design, Part Design, and create a new part called M6 nut, and click OK. Again, I'm going to click on Sketch of Workbench and create a new sketch on the XY plane, and I'm going to create a hexagon with the center at the origin, and the faces of the hexagon are going to be 10 millimeters apart. Exit the Sketch of Workbench. I'm going to use the path command, and for the length I'm going to choose 5 millimeters and click OK. Now the next thing you want to do is to click on Sketch of Workbench and create a circle on this face, and the diameter of the circle is going to be 4.918. Exit the Sketch of Workbench and use the pocket command to cut away the material. For the type, I'm going to choose up to last and click OK. Perfect. Now what I'm going to do is I'm going to create a point again, which is going to lie on the edge of this circle. And again, for the length, I'm going to click on 0 and click OK. I'm now going to create another helix, so C:helix. And the starting point is going to be the point I have just created, and the axis is going to be Z-axis. Again, pitch of 1 millimeter, that's fine. A height, you can go 10 millimeters, you can go less or more. The important thing is that you got your helix which goes beyond the surface of the nut. The thing is, you also want the helix to go beyond the surface of the nut from the other side. So for the starting angle, make sure you put in minus 720 degrees. Click on Preview, and as you can see, this ensures that the helix starts below the surface. And click OK. Perfect. I'm now going to create a plane which is going to be normal to helix at this point that I created at the beginning. So I'm going to click on the helix and then this point and click OK. I'm now going to create a new sketch on this plane that I have just created. So again, I'm going to create an axis. I'm going to create a line and make sure that I use the mirror command about the line. And now connect these two using another two lines. Perfect. I'm going to define the angle between horizontal and one of these lines to be 30 degrees. Distance between the y-axis and this line is going to be 3 millimeters, which is the radius of our bolt. Now this distance is going to be 0.541, and this length is going to be 0.125. Perfect. I'm going to exit the Sketch of Workbench, and I'm going to use the slot command again. And for the center curve, click on the helix. Now again, for profile control, click on pulling direction and click on this axis. Click OK. Close the warning. And as you can see, this created our nut and the thread within the nut. If you want to have a look on the inside, click on dynamic sectioning. And I'm going to create a section on this face. And I'm going to bring it here. And as you can see, this is a nice thread on the inside. Okay. One last thing to do is to click on the YZ plane, and I'm going to create a chamfer on the edges. So first of all, I'm going to create an axis, and this axis is going to be 2.5 millimeters from the bottom. So basically in the middle of the part. I'm now going to sketch in the chamfer manually. Make sure that the ends are connected. I want this line to be coincident with the edge of the nut. I want this line to be horizontal and coincident with this line. And this angle is going to be 30 degrees. And I'm going to define this length to be 1 millimeter. I'm now going to highlight the entire triangle, click on the mirror command, and click on the axis I created. Exit the SketchUp Workbench, and click on the Groove command. Now initially, you may get this error, which says Feature Definition Error. The specified profile isn't valid for the feature you want to create. Just go ahead and click OK. The problem is that CATIA automatically picked the axis for this command to be a sketch axis, something from Sketch. That's not what we want to do, so I'm going to click on this window and right-click and choose Z-axis. Click OK, and as you can see, this is what we want, and the axis has been adjusted. Click OK, and this is it. The nut is completed. I'm gonna go into properties of this part body, and I'm going to change the color to white. Click Apply and click OK. Perfect. Go ahead and save this nut. Go into File and Save. M6 nut and click Save. I'm now going to create animation out of the bolt and nut we have just created. I'm going to show you two different methods as well. So for the first method, you want to go into Start, Mechanical Design, and then Assembly Design. Within the Assembly Design workbench, I want to import M6 bolt. Go into your specification tree, right-click on Product 1, go into Components, Existing Component, and M6 bolt. Now, because this is the first component in my assembly, and I want to treat this as a fixed component, I don't want this component to move, I'm going to fix it using the Fix Component constraint. Click on the command, and then click on the bolt. This means that the bolt is now completely constrained. If I try to move it, it seems like I can. However, this Update button gets highlighted because I broke some constraints. When I click on it, it comes back to the original position, restoring the constraints. Now, if you can't see this Update button or any of these icons, just right-click on any of the other icons and make sure that both Update is enabled and Constraints enabled as well. I'm now going to import the M6 nut. And I need to make sure that I constrain the nut, because at the moment, the nut has just been loosely put into the position. I can put the compass on it, move it wherever, and as you can see, update is not required, because I did not break any constraints. So what I want to do is make sure that the axis of the nut is coincident with the axis of the bolt. I'm going to click on the coincidence constraint, and I want to choose the axis of the nut and axis of the bolt. Update the assembly, and as you can see, it snaps the nut onto the bolt, not the other way around, because bolt is fixed. Perfect. Now, the way I constrained this nut, I still left 2 degrees of freedom unconstrained. And that is, one of them is a vertical motion along the bolt. As you can see, no update is required because I did not break any constraints. And the second degree of freedom is if I put this compass on the axis of the nut, I can rotate the nut around its axis, again not breaking any constraints I placed in the assembly. And this is what I want. because I'm going to create a simulation in which I'm going to be controlling the vertical motion of the nut and also how it rotates around its axis. So I don't want to constrain those. Now what I want to do is make sure that I put the nut at the bottom of the bolt. So in order to do so, I'm going to click on this command in here called snap. With snap, you want to click on the bottom surface of your nut and the bottom surface of the bolt. And this makes the offset between these two surfaces 0, but doesn't place any constraints. I'm going to click on the command to disable, and that's it. Perfect. At this point, I'm going to click on Start, Digital Mockup, and DMU Kinematics. Now the first thing to realize about Kinematics Workbench is that any constraints created in the assembly design workbench are not automatically recognized by Kinematics Workbench. In practice, what it means is Kinematics Workbench doesn't know anything about this assembly. It doesn't know that the nut is supposed to be coaxial to the bolt. It doesn't know that. So normally you have a whole group of commands in here where you can put these constraints in manually. However, CATIA has got a neat feature where you can take the constraints from the assembly design workbench, so these two, and convert them into Kinematics Workbench. So to do that, you need to click on this command right here called Assembly Constraints Conversion. Now, if you can't see this group of commands, right-click on any of the other icons and make sure that DMU Kinematics is enabled. Click on the command, and a dialog window pops up in the bottom right corner. Now, it asks us to choose a mechanism. Because we haven't created any yet, I'm just going to click on New Mechanism, and I'm going to keep the name default. Click OK. It highlights both of our components, and I'm going to click on Auto Create. In here, it should say Unresolved Pairs 0 out of 1. Click OK. Now in the specification tree, under Applications and Mechanisms, you will get a Mechanism 1 with degrees of freedom which are equal to 2. Now this makes sense because the way we constrained this in the assembly design workbench was we kept 2 degrees of freedom of this nut unconstrained. And that was translation on this axis and rotation around its axis. The thing is, if we want to create a simulation, we need to drop this number from 2 to 0. Basically, we can't have any degrees of freedom, because if we have degrees of freedom, Kinematics Workbench doesn't know what to do with them. It doesn't know how to control them. So I'm going to expand this, and you will see I've got a couple of other groups in here. First of all, I've got my bolt, which is fixed, and that is something that was converted from Assembly Design Workbench. And then I have a cylindrical joint, which is something converted from coincidence constraint in the Assembly Design Workbench. So what I'm going to do is I'm going to double click here, and a dialog window in the bottom right corner appears. And I basically need to say that this M6 nut is going to be both angle driven and length driven. Angle because I want to control its rotation, and length because I want to control translation on this axis. Now the first thing I want to change is I want to say that the bottom limit is going to be 0 and also 0 degrees, and upper limit is going to be 25 millimeters because I want my nut to travel 25 millimeters up to the upper section of the bolt. And then the upper limit of rotation is going to be 25 times 360. Now you might ask why 25 by 360, and that is simply because the pitch of this thread is 1 millimeter, so one rotation is going to bring me 1 millimeter up. And because I want to travel 25 millimeters, that is 25 rotations, and one rotation is 360 degrees. So we have 25 times 360. Now, one last thing to do is at the moment, we can see that both of these directions are incorrect. We don't want the nut to travel down, and we don't want the nut to travel counterclockwise. So basically, I'm going to click on this arrow, and this will bring the nut up. Now, don't click on this arrow as well. This is a little bit confusing in CATIA, but if you click on this and try to change the direction as well, it is going to mess it up and it is going to bring it back into the original state. I can show it to you if I click on this So I want to change two things. I'm gonna click OK. Now you get the information that the mechanism can be simulated. But if I double click, as you can see, they changed back into the original state. So what you have to do is just change one of them and click OK. And this changes the other one as well. That's a little bit buggy in CATIA and it doesn't really make sense sometimes. Click OK. You can see that the degrees of freedom are now 0. Okay, so we are now ready to simulate this assembly. So what I'm going to do is I'm going to click on this icon called simulation. I'm going to click on mechanism 1 and click OK. You get two different windows. In one of them, you can control movement of your nut, and the other one is for simulation settings. So you get two sliders in here. One of them controls the angle, and the other one controls translation on this axis. Now, if you want to create a simulation, we need to combine these two together to get a nice motion. So that is when this comes into play. So in here, we can see a bunch of grayed out icons. But the one interesting to us is this number right here, 0.00. That is the initial state of the simulation, and that is what we are looking on at the moment. Okay, so let's say that I'm now going to bring both of these up to the upper limit, and I'm going to click on Insert. And now I inserted a new state that exists at a frame 1. So again, frame 0, this state, and frame 1, this state. I can now technically animate this. If I go into state 0 and click on play, it immediately jumps into state 1. And it jumps there in one step. I can change this, for example, to 0.01. I can come back to 0 and play this. And as you can see, this now looks much more appealing. So as you can see, the simulation stopped after it reached the upper limit. So what you can do is click on this button, go back into state 0, play it, and now what this does is it is going to go into the upper limit and then go back down. And then from the bottom, again go up and down. You can go ahead and pause, and you can click on the button again, and now it is going to go from the bottom limit all the way to the upper limit, and then start again. So jump to the bottom limit, and again go to the upper one. Something like this. Now with these buttons, you can click here to jump to the start, this to play, this to pause, you can play backward. You can go ahead and play around with these buttons. Okay, so now our simulation has been created. I can click OK. And the simulation is saved in Mechanisms, Simulation. If I double click here, I can always come back to it. You can create a video out of this simulation. So you can go ahead and in the same group of commands where you clicked on simulation, you've got something called compile simulation. After you click on it, you get a dialog window in the bottom right corner. And in here you can click on generate an animation file, click on file name, and you can choose where to save your animation. Let's say bolt and nut animation, and click save. Now for the time steps, you can click on 0.01. You can choose which simulation you want to create a video of. We only have one, so simulation 1, and click OK. It is now going to calculate the entire simulation and create an animation for you in the form of a video. Now the problem with this video is that if you play it, it is extremely fast because the whole video only has 1 second. Go ahead and close it. And it comes down, double click, to this. Because this one frame is basically treated as 1 second. So this is second 0, second 1. So if you want a slower simulation, let's say a simulation that takes 10 seconds, so you can actually see a nice movement on the nut, you need to create more steps. So what I'm going to do is say that at a t is equal to 1 second, I want my state to be at 2.5 and 900. And click on Modify. Now I'm going to do 5 and 1800 and click on Insert. And I'm basically increasing the translation by 2.5 millimeters and rotation by 900 degrees at a time. Click Insert. And I'm going to do this all the way to the upper limit. Perfect. Now, as you can see, I've got 10 different states, and I broke down my translation and rotation into these 10 steps. So now if I play it, it's going to be way slower. I can click OK. Let's generate a video. Again, file name, make it bolt and nut animation 2. Save. Time step, let's pick 0.01 and click OK. Now this is going to take a little bit longer to generate, but the result will be better. We can now play the video and see the difference. I'm now going to show you the second method to create a simulation of this bolt and nut. Go into Start, Digital Mockup, and DMU Kinematics. In the specification tree, right-click and go into Components, Existing Component, M6 Bolt. Click Open. Go into Product again, Component, Existing Component, and import your M6 nut. So now, instead of creating the constraints in the Assembly Design Workbench and converting them to Kinematics Workbench, I'm going to create them inside Kinematics Workbench manually. So first of all, I want to fix my bolt. So go ahead and click on the Fixed Part command, click on New Mechanism, click OK, and click on your bolt. I'm now going to grab this M6 nut and just bring it over here so it is easier for me to click on the axis. Click on this little arrow and click on Screw Joint. For the mechanism, choose Mechanism 1 we have just created. And now for line 1, I'm going to click on the axis of the nut and line 2, axis of the bolt. And I'm going to click on Angle Driven Only and say that pitch is 1 millimeter. Click OK. It now says the mechanism can be simulated. Click OK. Expand Applications, Mechanisms. As you can see, degrees of freedom are directly 0. Expand, go into Joints, and you can see your joint is now screw joint. And if you go into Commands and double click, this is what you can control. So I'm going to click on Simulation, Mechanism 1, OK. And in here, I've got my command, which is angle driven, right? Screw 1 angle. So that is from minus 360 to 360 degrees. So as I change the angle, you can see that the nut also moves up and down. So the translation is also constrained and tied with the change of angle. Click OK. Double click here and change the limits from minus 360 to, let's say, minus 1000, and upper limit 1000 degrees as well. Click OK. Go into Simulation from your specification tree, double click, and now the limits are different. So again, you can drag it and you can see that the nut also moves and rotates as well. If you want to change the limits, you can also click on these 3 dots and change the limits directly here. So you can say, for example, minus 1500 and plus 2000 and click OK. And you can generate simulation and then corresponding animation file in the same way as we did before. Okay everyone, this is everything I wanted to cover in this video. I hope it was useful, and I will see you in the next one.